All right, what do you got?
Who, me?
Yeah. So for each one, tell me whether or not it's infinite.
Okay, linear separators. They're seeming like half planes or lines or, depending upon the dimensionality. There are, of course, an infinite number of these things. There's an infinite number of lines.
So that we'll check that one off.
Right. So y equals mx plus b, and I can put any real number for m, any real number for b. It's an infinite number of those. In fact, there's not just an infinite number of those. There's like Aleph 1 infinite number of those. So that's good. we should talk about that one day. Artificial neural networks are exactly the same thing. They have weights. Those weights are real numbers. So even if there were only one weight, there's an infinite number of real numbers to choose from. So that's also infinite. Decision trees with discrete inputs. I have two answers for you here, Michael.
Uh-oh.
Answer one is, of course, it's finite, assuming there's only a finite number of features. The other answer is it could be infinite if I'm allowed to reuse features over and over again, even if they're useless to reuse. But that's sort of insane and silly, and no one would ever do that. So I think the right answer is to leave it unchecked.
Okay.
And then finally, decision trees with continuous inputs. Well, that's the same. We had a long conversation about this when we talked about decision trees. We can keep asking questions about them. So if there's sort of an infinite number of questions you can ask. I can say, well, is this feature greater than 0.1, and then ask if it's greater than 0.11, then is it greater than 0.111, then 0.1111, then 11111, and so on and so forth. So that is also infinite.
So basically, everything we've talked about, or nearly everything we've talked about, actually doesn't fit the analysis that we talked about last time.
What about KNN?
Yeah, so KNN is a little bit of a mess. I think you and I maybe don't completely agree on this one. So I think of KNN, the classifier that comes out of a KNN is defined by the set of data points that are the neighbors.
Mm-hmm.
And there's an infinite number of ways of laying out those points. So there's an infinite number of different KNN-based classifiers that you could have. But you have a counter argument to that.
Right, which is that if you assume the training set is fixed, and that's just a part of the parameters of the hypothesis space, then it isn't infinite. There's, in fact, only one. It all just depends upon Q, and it always gives you the same answer no matter what. So I think the hypothesis space, you could argue, is finite. It all depends upon what it is you're taking as part of the hypothesis space and what it is you aren't taking as part of the hypothesis space.
Right, sort of whether the data is built in or not. But it strikes me that these other methods are also similar in that if you bake in the data, then there's just the one answer. But yeah, KNN is weird, right? Because it's sometimes called non-parametric.
Right.
Which sounds like it should mean it has no parameters, but what it actually means is it has an infinite number of parameters.
Right. By the way, I don't think that's true about baking things in. So, for example, if I give you a set of data, there's still an infinite number of neural networks that are consistent with that data. There's a whole bunch of decision trees that are consistent with that data. So you don't always get the same answer every time. Certainly with neural networks you don't, because you start in a random place.
But if you bake in the algorithm and the data, and I think in KNN that's exactly what you're doing. But I agree that we can agree to not agree.
Agreed.